Math 110, Properties of Logarithms, Sections 5.4. The first property we're going to be talking about is the product rule. And this states that if I have log base a of two statements, m times n, I can break it apart into a form of addition by saying log base a of m plus log base a of n. So basically the logarithm of a product is the sum of the logarithms of the factors. So if I wanted to express as a sum of logarithms for log base 3 of 9 times 27, I can say that, well, this is my m, this is my n, so I can break this apart into log base 3 of 9 plus log base 3 of 27. Then from there I can say, well, 9 is the same as 3 squared, 27 is the same as 3 to the third power. And so now the log base 3 and the 3 will cancel out, the log base 3 and the 3 will cancel out, so I get 2 plus 3, which is going to equal 5. Now in this order, I want to express it as a single logarithm. So if I had log base 2 of p to the third plus log base 2 of q, this p to the third is m, this q is n, and I want to combine them together. So it's basically I'm going in this direction. And so I can express these two values here as products. And so I get log base 2 of p to the third times q. The next rule is called the power rule. And this says that if I have the form log base a of m to the p power, I can take that p and I can bring it to the front there. So it becomes p log base a of m. So expressing this as a form of a product, I can take this negative 3, bring it to the front. And so I get negative 3 log base a of 11. If you ever have a fractional root or a fractional power like this one, I can change that into 7 to the 1/4. Then I can take that 1/4 and bring it to the front, and so I get 1/4 log base a of 7. Here I have ln of x to the 6th power. I can take that 6, bring it to the front, and I get 6 ln of x. The third rule is the quotient rule, and it says that if I have log base a of m divided by n, this is going to be log base a of m minus log base a of n. So if I wanted to express this as a difference of logarithms, log base t of 8 over w, I can say that's a log base t of 8 minus log base t of w. Now a way that I try and remember this, because we're going to be looking at ones where we could have a series of things being multiplied in the numerator and a series of things being multiplied in the denominator. An easier way of looking at this is you can think of it as those that are in the numerator will be expressed as a positive value, those in the denominator will be expressed with a negative value. And so we're going to see that in some future examples, and I'll kind of come back to that concept. Now for the next one, if I wanted to express it as a single logarithm, log base b of 64 minus log base b of 16, I can express this as log base b of 64 divided by 16, which is going to be the same thing as log base b of 4. Now here are some common errors that people typically make. Log base a of m times n does not equal log base a of m times the log base a of n. The log base a of m plus n does not equal log base a of m plus the log base a of n. It's not like I distributed the log through. You can't do that. I can't distribute the log top and bottom to get that statement. And if I take whatever power it is to the entire log, it's not the same as move it into the front, because this is the power of the entire logarithm instead of just being the power of what my m is. So this one here, express each of the following in terms of sums and differences of logs. So the first thing that I can do here is my x squared and my x to the 4th can cancel out. And so now I have y to the 5th over x squared. And so now this is going to be my quotient rule, and so I can express that as log base a of y to the 5th minus log base a of x squared. Now I can take those powers and I can move them to the front. And so I'm going to get 5 log base a of y minus 2 log base a of x. This next one, once again I have that root, so I can write that as a fractional power. The power rule says I can bring that 1/3 to the front, so I get that value. Now, like I said previously, now we're talking about the quotient rule. I said if it's in the numerator, it's going to be expressed as plus. If it's in the denominator, it's going to be expressed as a minus. So that's positive, that's positive, that's going to be negative. And so it's 1/3 times this entire log, which is why I have parentheses around this entire thing. Now this log base a and this a cancel out, and so that's how I get this 2. And so now I have to take this 1/3 and I have to distribute it with every single value there. And so that's how I get this statement here. Now I can take this 5 and I can multiply it with the front there, and so I get 2/3 plus 1/3 log base a of b minus 5/3 log base a of c, which would be the answer that it's looking for. In this example here, numerator expressed with pluses, denominator expressed with minuses. And so I have to take this 5 and move it to the front, this 3 and move it to the front, this 4 and move it to the front. And so I'm going to get log base b of a plus 5 log base b of y minus 3 log base b of m minus 4 log base b of n. And so there's nothing else I can do. That will be my result. Now we're going to work backwards. What we're going to do is we're going to be expressing this as a single log. So what I need to do is take whatever's in front and I need to bring it up as a power first. And so I'm going to get log base b of x to the 5th minus log base b of y plus log base b of z to the 1/4. Now, positive goes in the numerator. Negative will go into the denominator. So I can say log base b of x to the 5th, z to the 1/4, because they're both positive, so that's why I put those in the numerator. This was negative, so that's why I put that in the denominator. And so I can rewrite this z to the 1/4 as 4th root z, and so that's going to be my answer. On this next one, ln of 3x plus 1 minus ln of 3x squared minus 5x minus 2. Positive, top. Negative, bottom. So I can write this as ln of 3x plus 1 over 3x squared minus 5x minus 2. Now I want to see if I can factor that, because it's quadratic. Maybe something cancels out. You always want to check. And so doing your xbox method, you'd find that it factors into this. Now my 3x plus 1's cancel out, and so I'm left with 1 over x minus 2 as my answer. Now we're going to be applying our properties, but we're going to be doing it in a different way here. It's going to be giving us some values, like log base 2 is 0.301, and log base a of 3 is going to be 0.477. And so it's going to give us some log, like log base a of 6, and what it wants us to do is it wants us to find what the approximate is going to be based upon these givens. So I have to creatively try and manipulate this 6 into where I can get a 2 or a 3. And so in this case, I know that 6 breaks down into 2 times 3. I can write it as a product. So I can now write this as log base a of 2 plus log base a of 3. Well, log base a of 2 is this value, so I can plug it in. Log base a of 3 is this value, so I can plug it in. Now adding them together, I get 0.778. Log base a of 2 over 3. I can write it as a quotient. Right? Well, this is the quotient rule, so I can write it as the difference. So log base a of 2 minus log base a of 3. So now plugging in the values again, simplifying, I get negative 0.176. Log base a of 81. This one's a little bit more abstract. So can I write 81 in terms of 2 and or 3? In this case, 81 is the same as 3 to the 4th power. Now I can take that 4 and move it to the front. Log base a of 3 is going to be 0.477. And so 4 times 0.477 is going to give me 1.908. Log base a of 1 over 4. I can simplify that into 2 squared. And so I can write this as log base a of 1 minus log base a of 2 squared. I can bring that 2 to the front, and I know that log base a of 1 is 0. Log base a of 2 is 0.301. So multiplying that through, I get negative 0.602. Now log base a of 5, nothing we can do. I can't break it apart into this because that's illegal. There's no way I can break down 5 into factors of 3 of 2, so I can't move on from there. It doesn't work. Now we're trying to simplify logs and exponential expressions. Previously in the past lesson, I kind of did this manipulation, but I didn't formally define it. Now I'm formally defining it. If you have log base a of a to the x power, they're going to cancel out and you're left with x. So in this one, log base a of a, that cancels out, I'm left with 8. ln of e, those cancel out, I'm left with negative t. Log 10 of 3k, well this is log base 10. Log base 10 and 10 will cancel out, and so I'm left with 3k. My a and log base a cancel out, so those cancel out, I'm left with k. E and the ln cancel out, I'm left with 5. 10 and the log cancel out, and I'm left with 7t. And so we're going to be using this principle in our following lesson when we're going to be solving logs and exponential equations. If you have any other questions, please leave them in the comments.